This
Online?
conference will now be recorded.
Good morning, whether it's audible.
Yes, Srinivas.
Yes, thank you. So, once again, very good morning to everyone. So, today here we are for physical design demo. So, the batch starts from tomorrow, right? So, the agenda of today's discussion is three things. One is physical design. What is physical design? What we do in physical design, and our syllabus coverage. So, what we cover in physical design in our course, right? For the first thing, what is physical design and what we do in physical design and what is our syllabus coverage. That's the first thing. Second thing is we are going to discuss about our course structure, right? How the course is conducted. So the course structure. Third thing is your queries, whatever queries you have regarding placements, everything, right? We are going to discuss this. So these three aspects we are going to discuss today. So that is what our main agenda is. So before going to this physical design, just I will give a small introduction about our course, how our course runs. So then I'll go to what is physical design and why physical design, right? See, our course is divided into two topics. One is basics and one is advanced physical design, right? So in the basics, so total course duration is 6 months. So here it is accounting for 5 months, 5.5 months, but total duration is six. It may extend to 6 months, right? So 2.5 months is for basics. So basics what we cover, right? For physical design, what is very essential, you have to be knowing before going to the advanced class. Those basics are covered. If you don't have job, you can sit here, or you can sit in the middle. So in basics, we cover about digital, GVim, Unix, Linux, Pickle. So digital, you already know. Everyone is already knowing digital. Just we are going to brush up like what is sequential circuits, what is combinational circuits, what is flip flop, what is latch, what is difference between latch and flip flop, what are the how to implement any final state machine. Then GVM basics, GVM is a text editor. That basics we'll discuss. Linux are Unix operating system because every EDA tool, what we work, EDA means electronic design automation tool. What tool we use for physical design, that is installed in Linux operating system. See, compared to Windows, Linux is very benefit. We have more benefit of Linux compared to Windows because Linux we can handle through commands. If I want to create 10 folders with some name, right? I right click new folder, create, right click new folder, create. That is how we create in Windows for a single command in Linux. So, what are the commands to copy a file, to copy folder, to create file, to grep anything from the tool, search and replace in the file. So, all those things you learn in Linux. Then you have tickle basics, very, very important. Tool command language. So tool command language, every EDA tool will understand only TCL. So you're going to learn about tool command language syntax plus some example programs. CMOS basics. What is CMOS? What is semiconductor? What is PMOS, NMOS? What is CMOS? What is layout of CMOS? What is fabrication steps? What is power? What is delay, cell delay? So all those things you're going to learn in CMOS basics. Next is physical design basics, like some important terminologies like what is core area, die area, what do you mean by cell delay, what is the meaning of transition. So all those things, some important terminologies we are going to learn in physical design basics. So this entire basics is for 2.5 months, and digital and CMOS and physical design basics. Digital, CMOS and physical design basics, all these three are presentation type. So mentor will give the presentation and he will explain and you will follow that. Assignments will be given, you will follow the assignments. But GVIM, Unix and Tickle is hands-on. So mentor will do, along with mentor you will also do parallelly. So these three things are is hands-on session in basics. So when it comes to, so how this basics learn, it is done. Only I'm talking about basics, right? So basics is done Monday to Saturday, 3 hours every day. I'm not discussing about this advanced part now, right? I'm only discussing on basics. So 2.5 months you have Monday to Saturday, 3 hours. And Saturday and Sunday is optional. It is not for you people. It's not for regular students. Those who can attend on Monday to Saturday, there will be some working professionals. Those who cannot attend on Monday to Saturday, they can attend on Saturday and Sunday. Separate sessions will be done for them. Either attend Monday to Saturday or Saturday to Sunday. Don't attend both. So our suggestion is attend Monday to Saturday. So Monday to Saturday you have session every day for 3 hours, and you have live recorded videos given to you. So if session is done, that recorded videos will be given to you. By chance, if you miss the session, you can see the recorded videos. And when we come to advanced course, this advanced course PD advanced. See, PD advanced, we are doing everything from the basics of PD advanced to the till the sign off checks completely by using synopsis tool. See, industry uses two types of tool. One is synopsis and cadence. But we do by using what? Synopsis tools. That is for 3 months. So what tools we use? DC. DC is for design compiler for synthesis. ICC2 and Fusion compiler for physical design. ICV is for physical verification. Prime time is for static timing analysis sign off. Prime time and star ASIC. So these tools we use. And this advanced physical design, which is for 3 months, right? It is divided into two things. One is Monday to Thursday, you will be doing lab. Lab means project, hands-on project. It is from Monday to Thursday. So mentor will work, along with mentor you will also work. It's hands-on fully. With the tool you will work. Generally, it will be from 10 to 1 p.m. or it will be from 2 to 5 p.m. Either in the morning or in the afternoon. Per day 3 hours. Weekend, Saturday and Sunday, you will be having theory sessions. Only theory, Saturday and Sunday, for 3 hours. I repeat once again. Weekdays, there is a lab session. Lab means project you will be doing, mentor will be doing, along with that you will also do. So that lab session happens from Monday to Thursday, and weekends you are going to do what? We are going to do theory sessions. But those who cannot attend the lab sessions on Monday to Thursday, only for them we will do lab session on Saturday and Sunday. Lab session will be on Monday to Thursday itself. Only the persons who cannot attend on weekdays, only for them, the lab session will be from 2 to 5 p.m. after the theory sessions. So every candidate will attend theory session on Saturday and Sunday morning. Afternoon there will be lab session only who can attend on weekdays. The students who can attend on weekdays, they'll attend on Monday to Thursday. And for this also the live recorded videos are given, right? For this also, the live recorded videos will be given even for basics as well as for what? Advanced classes. And last thing is we have 1 month advanced course on cadence also. The fees is different for that. Whatever fees we charging, it is for basics and PD advance. So PD advance with cadence you want to do, you have to pay some extra fees. Right? That is cadence. Genus is for synthesis, Innovus is for physical design, Tempus is for physical timing sign off, and PVS is for physical verification. Same tools, right? Here ICB, PVS, prime time, Tempus. So fusion compiler, Innovus, DC, Genus. So if you want to do this course 1 month separately, you have to pay separate fees for it. So basics plus advanced, the fees is already told to you. Cadence is separate. What is they have mentioned? Yes. Including cadence, it will be 75,000. Just I'll confirm with him, manager. Wait 1 second. Give me time. Just Okay. So yes, sir. So 95,000 including cadence. So there is discount on that that you can talk to the institute, right? The discount on that is available. You can talk to the institute because I'm not sure about the fee structure. So if you opt for cadence, right? 75,000 includes cadence also. On top of that, you have some discount. So including cadence, additional 1 month. So total course duration is 7 months, including cadence. Right? So this is about our course structure is. So if you have any queries, just for 2 minutes, you can ask me. Yes, theory sessions will be on Saturday and Sunday. Weekend, Monday to Thursday, there will be lab. Yes, project specification. You're talking about that. Right? Project specification is see the project. What we do is which has standard cell count of 52,000 and macro of 40. So one more design what we have with cadence is that is multi-voltage design what we have. It's synopsis what we are doing. What we do with cadence is almost 62,000 and macro count of 48. 48. Yes, clock is we have three master clock, two generated clocks, total 5 clocks. For one design, second design we have 3 clocks. That I'll show you the project specification at the last. Now please tell me. Yes, installment I think it is there. You can talk to the institute. Installment is available. You can talk to the institute regarding the installment. Please tell me. So maximum operating frequency of the clock, what we do it in synopsis is 500 megahertz. It's almost same 500 megahertz. Same 500 megahertz. Cadence is just separate design. It is not the same design, separate design. But what we are discussing synapses, what is the equivalent command for that? So we have attribute commands in synapses. How to use the dbget commands in Cadence. So everything is discussed in Cadence. Only tickle. See, Perl is, see, Cadence, these EDA tools, whatever we have, right? EDL tools will understand only tickle. These tools, Fusion Compiler, Innovus, Genus, they will understand only tickle. So to use this tool, tickle is compulsory. See, Perl Python is on top of that you can use for automation. PD engineers will never work in Perl and Python. That is separate engineers who is working automation. Automation means build a wrapper on top of the tool. Wrapper you will build, you will have to invoke the tool, create the directive structure, form the directive structure, dump the reports. So if you want to work, if you want to make automation, then you should go for Python or Perl. But to work with physical design, tickle is sufficient. Same operation can be done with tickle also, but Python can do better operation. If, for example, I have a file, from that file I have to read the information. That I can do it by using tickle. But Python has better structures. We can do good in Python. So that is not only physical design, it is just automation. If you want to do separate on top of every design or every even software, even physical design, let it be any tool, automation is required. You cannot create a directory structure, right click, create a directory structure. So once if I tell make directory, automatically it has to create a directory structure, it has to create the files. So to do that, what we can use tickle, but instead of tickle, Python is the best option. So to do automation that is required, but for physical design, tickle is sufficient. Our tools, the synopsis and cadence tools will understand only tickle. Not even single command of Python they can understand. But Python is for automation on top of that. So career, right? You have experience in some other domain and you have some concern about your career, right? So only thing I want to comment here is I'll just give one small introduction about the placements, right? Then only you can understand about how the placement works. See, in we have two types of industries. So those are called as service based and product based, right? Product based are they are involving in they are responsible for producing the product. For example, you take example of Qualcomm, take example of Intel, AMD, Nvidia, MediaTek. All these come under the category of what? Product based companies because they at last end they will produce the products. So every employee of product based companies is not from their company, right? They will also take employees from what? Service based companies for their projects. So service based companies, there are a number of service based companies. Example, so nowadays even IT industry is entering into service based companies of semiconductor. So many IT companies we have and many we have like in semi, Nippon Time, uh, Wipro. Many companies are entering as service based companies. Yes, Capgemini, right? So they will hire you. Right? They will hire you. They will give you small training, and they will put into the projects of what product based companies. So physical design flow is same, but what is the challenge you will face in the new projects? What is the challenge? What is the difference? See, I'll just give you one example. When you go to any music class, right, you will always play the song which is already sung, already it has done. It's very easy to do that. Already play the song which is already created, already composed, right? So singing the composed song or practicing the composed song is very easy. But when you are asked to sing the new song, there comes a lot of problems. Similarly here also. Already project is done, doing the project is, but when you start doing the project, right, n number of problem comes. The problem may not from your side, right? It can be from the RTL side, it can be from the constraint side, it can be from the uh, UPF side. So many problem comes. So what is your role? How to handle those problems? See, if any error comes, error is not coming because you have done the error, right? If any error comes, what is the role of physical design engineer? You should identify why this error is. So in the meeting, you cannot tell that I am getting this error. I don't know why it is, right? I should tell that okay, I am getting this error. Here, isolation cell is not added. So because in the UPF isolation strategy is not properly defined, I have checked the UPF. In the UPF isolation strategy is not properly defined. So I want to talk to RTL team to define it properly. So now you are giving your lead clear cut idea what is the problem. Who has done the mistake? It is not that I have not done the mistake, I don't know what is the error. Right? You should tell that who has done the mistake. So companies what they will see is how active you are, how easily you can understand or learn the concept, how easily you can adapt to the changes. First thing. Second thing is work pressure. Right? Physical design engineers have a little bit work pressure when it comes to the near to tape out. Tape out means when we are closing the projects. So we have inputs from all the sides, like IR drop, sign off, things. So at the time, some pressure we have to handle. We have to handle the projects steadily, right, without losing the focus. How dedicated you are. So service-based companies will hire you and they will put you into the projects of what? Product-based companies. What is the probability of product-based companies hiring you? What is the probability of service-based companies hiring you? I can tell 30-70. 70% of chance you'll get from what? Service-based companies. 30% you can get from product-based companies. Why? Product-based companies will not hire the freshers. So at least they require. See, nowadays they are hiring. So nowadays, so recently we have seen Intel has hired. Intel has hired some freshers also. So they will hire. It is not that they will never hire, but generally they will not hire freshers. They will hire with at least 2 to 3 years of experience because they don't want to waste time in training. So service-based companies is not like that. So they will hire even freshers. They will even hire there some experienced candidates. So mainly preference is given to experienced candidate in physical design especially. Right? Why? Because if you have 3 years of experience, then only you are allowed to take the projects of what? Product-based companies. 2.5 years or 3 years. No problem. Service-based companies, if you have year gap, everything, the service-based companies will manage to create this experience. But if you're very good enough, if you have done your course very good, right? You've done your course very good, and you're very bright. So if your pass out year is 2013, they'll put some experience on you and they'll send you to the product-based companies. But your pass out year is 2025, they cannot put you the experience on top of it. So I'm answering to the question of if you have year gap, what is the advantage? So here there is an advantage. Service-based companies will put you the experience. To put the experience, there should be some pass out year should be 3 years before. So again one more question comes whether service-based companies will not hire the freshers, they will hire for sure. See, there is something called as ODC project. ODC means off the shelf. Means entire project of product-based companies. Entire project of product-based companies will be given to what? Service-based companies. Here, two things are there. One is employees of service-based companies will go to product-based companies and they'll work. That is first thing. That is work. That is with temporary employment. I am the person of service-based company. I will go and work with product-based company, and I am a temporary employee of what? Product-based company. Second thing is product-based companies will give some complete project to what? Service-based companies. At the time, what service-based companies will do? They will look mostly for freshers because of they can pay less salary because when the new project is there, right, there will be n number of works to do. It's not very complicated, but simple works will be a number of works. So the companies like if you talk about what are the companies like Wipro, Capgemini, and all right? Well, they get a complete project ODC, then they will even hire the freshers and even they will allow to work for the freshers. So this is how the placement works. So there is a 30% chance that you can enter into product-based companies if you are good, and 70% chances are you can enter into service-based companies. So when you enter into service-based companies, right? So they will also a little bit train you. Small amount of training they may give you, like how to answer in the training means they will not train you the course for sure because they will not be having tools and all. So they will train you like what to answer in the client interviews. If product based companies, they will also do one interview before giving you the project. What to answer there, how to answer, everything they will do, and they will put you in the projects of product based companies. So this is how the placement works in semiconductor. Not only here, everywhere. Right. So we will get a call from companies and we will post you that requirement. Based on that we will collect your resumes, then we'll forward the resume to the companies and the companies will contact you. So this happens after the course completion. After the course completion, if any requirement, we will forward you, and we will collect the resume from you, we'll forward to the companies, and if you, then directly you'll get a call. Right. This is how the placement is. So for placement support, we conduct regular test and assignments. We'll conduct the mock interviews. Mock interviews means our institute only will conduct the imitation of interviews, how interview happens and what is the feedback, where you have to improve. Right. So we will also help you in building the resumes and other soft skill training like improving your communication. If you're not good in communication, we will also help you in improving your communication. Right. This is about your placement information. So just if you have anything queries, you can just ask me in 2 minutes. Any queries you have?
Hello,
Yes, please tell me.
sir. Am I audible to you?
Ah, yeah, you're audible. Please tell me.
Okay, sir. Uh, Sir, actually, like you explained those TCL and those all our cadence and snipposis all.
Ah,
Hello.
please tell me. Please tell me.
Yeah, sir. Sir, am I means am I able to get everything? Like, sir, at this time, by this time, I don't know anything. Means on this those TCL and all you explained.
No, that is we are doing it, right? We will do the tickle. That basics we will
Okay,
cover.
so from the basic to advanced, I am able to get everything, sir. There.
Yes, basics we cover everything. Then only we will allow you to attend the advanced class, right? We will
Okay,
cover these
sir.
concepts.
Okay, sir. Sir, one more question, sir. Like you explained, for weekdays, like Monday to Saturday.
Yes. See,
Sir.
basics will be from. See, basics has two courses, right? One is weekdays and weekends.
Yeah, yeah.
The person who can attend on weekdays, he can attend on weekdays. And by chance, if you cannot attend on weekdays, then opt for weekends.
Okay, sir. So, sir, now I am in Odisha, sir. So I want to relocate there, sir, in Bangalore. So that will take 2 to 3 days, na?
Yes.
Yeah. So, sir, I can attend that on Sunday and Saturday, na?
You can attend on online, first of all,
Yeah,
if you're
sir.
not
Yeah.
available, physically available. If you even can't attend online, you will be given recorded videos. See, the
Okay.
course, if we start from tomorrow, we will not start with directly from the concepts of digital. We'll start with GVM basics. Right? GVM basics is very simple. If you are missing also, what we can do is you can attend again once again. We will do once again for next batch. If you are doing attend, you can see GVM is just a simple thing. It's only 2 days course. See, as we know,
Yeah, yeah.
students can't attend directly from Monday due to some reasons, relocation, everything. So we start with GVM basics. So GVM is
Yeah, sir.
simple thing. So you can, if you were missing it by chance, then you can attend once again when it happens for next month. You can request the institute and attend for
Okay,
next
okay,
week.
sir. Sure.
Only GVM, right? GVM is nowhere concerned. There is no relation between one topic to another. Only Unix has relation to tickle. Some Unix command should be knowing when we do tickle. So other apart from that, every topic is different. So if you're taking 1 or 2 days to relocate, then if you miss GVM, you attend again once again when it is done for next time. But we will not be knowing you have missed. Right? Intimate the
Okay,
institute
sir.
that I have missed and I'll attend later.
Yeah,
So we
sure,
will
sir.
support for that.
Yeah, sir. Thank you, sir.
So any other doubts? See, everything is done from the basics, sir. But what we expect from the student is to bring your laptops. So we are install your tools in your laptops, whatever tools required, and be active. And if you have any problem, anyhow, if you are coming offline, the office is there. You can discuss this in office. Anything you're not understanding or anything problem you have, right? You can discuss in office to get the solution, or intimate in individual official WhatsApp group. See, we have two groups. One is normal group where everyone are present. All the students are present for this batch. Admin is present, manager is present, everyone are present. But in that group, we generally used to post the schedules. Right? Post schedules. Every week we will post the schedule. What class you have for this week, right? Even though you know, but just we'll post just as a reminder. But for every student, there is a separate group called as individual official WhatsApp group. So in that group, you will be there, admin will be there, manager will be there, and mentor will be there in every group. For every student, that group is separate. In that group, if you have any queries, you can post. If you're attending online, because many students will attend online, in that group, you can post all the queries, even regarding the sessions. And by chance, if you want to retake the session also, right, you can post there. You can post anything in that group, or you can meet in the office, whatever office we have, you can meet in. Yes, you can ask Kaushik, you can ask your doubt.
Today, yeah, we took online course like e-learning. So how are you going to assign tools to us, like install the tools?
Please come again. What you told? E-learning.
We are taking e-learning course. So how will we be assigned tools to us, like
So e-learning course
for
record
this?
videos will be given, right? From the experienced lecturer, right? So record videos will be given, and the record videos time duration will be there, and for you the tool will be given along with that. So tool username and password will be given in the record videos. Also, we have already discussed how to use the tool, how to install those tools, so you can utilize that.
Yeah, yeah, okay, thank you.
Yes, I think I have covered a little bit basics about our course details, right? So if you have any queries again, so please you can ask me again in the last. Any other queries you have, you can again ask me in the last. After completion of this session, you can ask me any queries regarding the course structure or regarding the placements or anything. Right? So now today, fiscal design, right? So fiscal design. So fiscal design, I can separate it as before going to fiscal design. We will separate the IC. What is IC? Everyone know, right? Everyone know what is IC. This is called as what? IC, integrated chip. So this IC integrated chip is capable of handling many operations. So in an IC, how many transistors you may expect? See, gate count itself will be in crores, 3 crores. 3 to 4 crores in an IC gate count. One gate is made up of what? At least two transistors. So transistor count will be in double than the gate count. One for inverter you need two transistors. For AND gate and all you require what? Four transistors. So it will be like more than 15 to 20 crores transistors you can see in one IC. So entire agenda of physical design or front end, right, to design an IC. See, when we talk about this IC thing is divided into two things. One is IC fabrication and IC design. Where the IC fabrication happens? IC fabrication happens in foundry. So foundry is a place where we fabricate the ICs. So we have many foundries like TSMC, UMC, Global Foundries, Intel Foundries. We have what? Samsung Foundries. So what is chip design? Chip fabrication is a unit which is going to fabricate the IC, but chip design is a team which is going to design the IC by using a EDA tools. What is EDA tools? Electronic design automation tool. So chip design, they will use EDA tools, electronic design automation tools. So in the software, we will design the IC. Using software, we will design IC. After designing an IC, we will give some file to fabrication unit. After that fabrication unit will fabricate the IC, and that IC will come to the market. Market did not directly come, it will come to the appliances, what we use, our mobile phones, right? So even our mobile phone has IC from most of the IC is from Qualcomm. So now one question I have, what this chip design team will give to fabrication team so that fabrication team will fabricate IC for us? What is transferred?
Layout.
Yes, good, right? What we give is chip design team is going to transfer GDS file. What we do? GDS file. GDS means graphical data stream information interchange. So this GDS file from the chip design team is designing the chip by using what? Software tools. After designing a chip, we give at last what we will give? We will give a GDS file to the fabrication unit. Fabrication unit will fabricate the fabricate the design, fabricate the IC by using what file? GDS file. So ultimately, GDS file is the handshaking unit. So what is the content of GDS file then? What GDS file is? What is full form of GDS2? GDSII, graphical data stream information interchange. So what is GDS? GDS has layout and layout of cells and its connections, right? This is the layout. So if you talk about any tool, any layout, I don't know how many of you know layout or not. If you doesn't know layout, what is layout, then we will cover in CMOS basics. CMOS basics we have used for that purpose only. So you know what is CMOS inverter at least, right? CMOS inverter. So this CMOS inverter has what? Top you have VDD. So here you have PMOS. At the bottom you have NMOS, and this grounded. This is PMOS. This is NMOS. This is V in. This is V out. This is CMOS inverter. Right? How to fabricate the CMOS inverter? First, you will be having P substrate, right? I hope everyone know the fabrication. First, you will be having what? P substrate. In P substrate, you can fabricate what? NMOS. So you have NMOS source and drain, right? This NMOS source, NMOS drain. So this N-type semiconductor. This N plus source, N plus drain, source and drain. On top of this, you have what? On top of this, you have silicon dioxide. On top of this, you have polysilicon. Polysilicon is going to act like a gate, right? This is going to act like a gate. This is gate. This is source. What is this? Drain. Or I can make this as source. Anything I can make as source. This I'll make it as source. This I'll make it as drain. This I'll make it as drain. This I'll make it as what? Source. This is your NMOS. This NMOS. How to form PMOS? What is this? This is silicon dioxide. What is this red color? Polysilicon. So what is this? How the PMOS is formed? PMOS is not directly formed. So to form the PMOS, you should be having what? N well. First you have to form the N. Form the N well. So how to form N well? We will discuss in the fabrication steps. Right? In N well, we are going to form what? PMOS. So PMOS has P plus source, P plus drain. On top of this, again you have silicon dioxide. On top of this, again you have what? Polysilicon. This is source. This is gate. This is drain. This is P plus source and drain. So this is the fabrication of CMOS. What is CMOS stands for? Complementary metal oxide semiconductor. Why it is called as complementary?
Both PMOS and NMOS is there.
Yes, both PMOS and both acts in the complementary fashion. Like if I am off, you turn on.
One is on.
If you are off, I will
Yeah,
turn on. So both operates in complementary fashion.
on.
So this is the structure of your CMOS inverter, right? So if you want to write the layout for this, how will you write? What is layout? Top view. What you see from the top of the IC, right? That is called as what? Layout. So how do you write the layout of CMOS? So layout means first you should be having what? P substrate, right? This is your P substrate. So inside this P substrate you should be having what? N well. So I'll create the N well here on the top. N well. After N well, you should be having this VDD and VSS. So by using metal layer, right? Blue color is a metal layer. So I'll use one VDD here, one VSS here. VDD and VSS. This is VDD. This is VSS. In between you have what? Here you have diffusion, right? This is called as what? Diffusion. P plus diffusion. This is P plus N plus diffusion. So in between diffusion, if you cross polysilicon, what is formed? Transistor is formed. So this is a polysilicon, and this is a diffusion. And here you cross polysilicon, a transistor is formed. Now you connect this. So now if you see, this I'll call it as source. Anything you can make it as source. This I'll call it as what? Source. This I'll use it as source. This I'll use it as what? Drain. This I'll call it as source. This I'll call it as what? Drain. And this is called as what? Gate. This is P plus. This is P plus. What is it? This is N plus. So you can see here the gate of PMOS and gate of NMOS both are what? Shorted. So this gate and this gate both are what? Shorted to each other. So here also you can short gate and gate. Short gate and gate by using same polysilicon. That you can give it for the connecting purpose. This is a polysilicon, and here I will connect this to metal layer. I will use one metal layer here. I will connect to metal layer. While connecting to metal layer, I should use one contact cut. I use one contact cut and I will connect to metal layer. So this is your V in. This is V in. So polysilicon metal layer directly you cannot connect. What is this called as? Contact cut. Because polysilicon is in the bottom layer, M1 is in the top layer. Means layer is different. It is in the bottom, polysilicon, M1 is in the top. So in between you should be having a connection. That is called as what? Contact cut. Now this source of your PMOS is connecting to what? VDD. This source of NMOS is connecting to what? Ground, VSS. Right? The same connection I will do now. So this you connect to VDD. Right? This you connect to VSS. By using metal layer, right? I mean connection by using what? Metal layer. So this is metal layer. This is what? Metal layer. But what is this? This diffusion is a semiconductor. So semiconductor and metal layer directly I cannot connect. Again, I should use what? I should use some contact cut here. So here one contact cut, here one contact cut. Because semiconductor is in the bottom layer, but metal will be in the top, like this. Both have to make a connection. That is called as what? Contact cut. Now what is happening here? This drain and this drain both are what? Shorted. So make drain and drain short by using metal layer. So drain and drain short. I am using what? By using metal layer. So here one contact cut. So here one contact cut. Use here one contact cut. So this is V out, right? Now you can just summarize the layers what we have, right? What are the layers we have? This is called as what? P substrate. What is this layer? N well. What is this yellow color? P plus diffusion. So this is N plus diffusion. This red color is polysilicon and blue color is metal. So this is called as layout of a cell, right? Layout of one inverter. But GDS is not having layout of only one inverter or one cell, right? It is having layout of what? Previous cell, next cell layout. How they will make connection, right? This, for example, output of this cell is connecting to input of this. Output of this is connecting to what? Input of this. So connection of layout of cells is called as what? GDS. What is GDS file? Connection of layout of cells is called as what? GDS file. That GDS file we will give from chip design to what? Chip fabrication. Then chip fabrication will fabricate IC for us. So at last, what is going? Layout is going to the. This is called as layout. By chance, if the layout is you are not aware about the layout, how to draw the layout? I cannot teach you now from the basics because we have only 3 hours of time. So, but we will cover in our CMOS basics from the beginning how to draw the layout. What is the meaning of why there is polysilicon? Why there is metal? Why there is a diffusion? What is NMOS? What is CMOS? Right? Everything we will cover in the CMOS basics. Now, as we proceed to the concepts, now we understood that at last chip design team will give the GDS2 file for what? Chip fabrication team. Now the question starts from where the physical design starts. Physical design starts from ASIC design flow, right? Physical design starts from what? From the ASIC design flow. So to understand why physical design, what we do in physical design, first we have to understand the ASIC design flow. So ASIC design flow, if we focus, this is the ASIC design flow. We'll start from chip specification, chip architecture, RTL design, RTL verification, floor plan, partitioning, DFT, synthesis, placement, CTS, routing, sign off. Correct. So after that, chip fabrication, packaging, and ultimately chip will come out. I think because of this color issue, you cannot see that. So first step is chip specification. So what is chip specification? Chip specification means, so first is, see, highlight the steps now. Chip specification is the first thing. Next thing is RTL design. Next thing is what? RTL verification. Next is synthesis. After synthesis we have what? DFT. After DFT we have what? Physical design. So now chip of specification. What is chip specification is? Chip specification is nothing but what are the requirement of chip, what blocks you want in a chip. In a chip you require the RF module, whether you want Bluetooth module, Wi-Fi module, USB, PLL. PLL is for what? Phase lock loop. PLL will produce different clock frequencies. So your crystal oscillator will be of only one clock frequency, but each block will work with different clock frequencies like 500 megahertz, 250 megahertz, 300 megahertz. To generate the different clock frequencies you will use what? PLL. So ALU, arithmetic logic unit, graphical processing unit, control unit. So what are the blocks required in your chip? That is decided from chip architecture team. If you want to implement this type of function, then what are the blocks required in your team or in a chip, right? That is decided from chip architecture team. They will draw the layout. Layout means it is not the layout using transistor level, just blocks. These blocks are required, and output of PLL will go to what? Input to GPU, means it is going to give the clock to GPU CU, and output of GPU will go to ALU. Like that, they will entirely they'll design what is the entire requirement of chip. So nowadays designing is very easy because of previous projects. See, new chip is the extension version of what? Previous chip. If you take this i5 processor of Intel, it is extension version of what? i3 processor. Whatever i3 processor you have, add some additional features, make it as what? i5. So architecture team will also take the results of previous project, blocks of previous project, and they'll decide what the blocks required. So mainly they will decide what is a block and chip area, what is the power, estimated power, how much power this chip may consume. That is estimation. Okay, this much power it may take. Really, we are not sure. Ultimately, what is the power we'll get only in the last. But just they will estimate what is the power requirement, what is the clock frequency for each block, and what is the cost. Everything they will decide. So based on this, what is the next step? RTL design. What is meaning of RTL design? Now, RTL engineer will start write the Verilog code for each block. That is called as RTL design. Why Verilog or VHDL? My question. Why we have to use Verilog or VHDL to describe any design? Why not directly we can write the structure? Yes. Why Verilog or VHDL? Any answer?
Normal high level languages don't have concepts like concurrency like this, which are essential for hardware design.
Okay. That is also one of the answer. Why we have to use Verilog or VHDL to describe any circuits? Because Verilog or VHDL will allow us to describe the circuits based on its behavior, not on the structure. So just I will give one example, right? Tell me you have 2:1 mux, right? You have 2:1 mux. Select line and output Y. So this 2:1 mux, how many can you write the internal structure of 2:1 mux by using gates? Okay, we are not write the internal structure, leave, right? But how many can you tell its behavior, how it behaves? Based on select line and Y. If select line is 0, what is output Y? Y is going to take what? I naught. If select line is 1, Y is going to take what? I1. This is the behavior of what? Mux. So if you remember this behavior, that is sufficient to describe in Verilog or VHDL. You need not to remember the internal structure of that mux, right? How do you represent this? You will use the if statement, right? If S equals 0, Y is going to take what? I naught. Else, Y is going to take what? I1. This is the behavior description, right? This is the behavior of this mux, correct? So you are describing the any circuit based on its behavior, not by the internal structure. That is a benefit of using what? Verilog or VHDL. Use the if statements, use the case statements. Describe the behavior of a circuit. So this describing is very easy, but when you take the complex circuits, it's very difficult. Complex circuits you can describe only based on its behavior. You cannot write the internal see for mux. Writing the internal structure is not very difficult. You can write it, but for bigger circuit, directly writing the internal structure is very difficult. So what they will do first, if you have any bigger design, first they will write the behavior of that by using what? By using finite state machines, FSM. For example, you have ATM machine, right? So in ATM machine, if you take, there is a reset state. What is the state called as? Reset state. If card is not entered, right? Reset state, it will be always in a reset state if card is not entered. Means if card is not entered, means 0. Sensor will give logic 0. Output of sensor is giving what? Logic 0. If logic 0 I am getting, then I will be in what state? I will be continuously in the reset state. If card is entered, the sensor will give what? Logic 1. So if card is entered, go to next state. What is this state called as pin entering state? Pin enter. Now you have to enter the pin. If pin entered is correct, first we'll go with wrong. Right? If pin entered is wrong, or pin is not entered for long time. Two conditions: pin entered is wrong, or pin is not entered for long time. So then go back to what state? So what I have to do in this state? I have to check whether pin entered is correct. I have to wait till pin is entered. If pin is not entered for long time, go back to what state? So produce logic 0 and go back to what state? Reset state. If pin entered is wrong, again produce logic 0 and go back to what state? Reset state. If pin entered is correct, then go to amount entering state. Amount state. I have to enter the amount. Just I am giving a general example. In amount entering state, what you will do? You will wait till person is entering the amount. If the amount is not entered for long time, go back to what state? Reset state. If amount entered is wrong, means amount entered is more than its balance. My balance is 500, but I'm asking 1000 rupees. Then it's a violation. If amount entered is wrong, or I'm asking the amount like give me 433 rupees, bank cannot, ATM cannot give. It should be in multiple of hundreds or 500s. If amount entered is wrong or amount is not entered for long time, then go back to what state? Reset state. If amount entered is correct, then put logic 1. output is logic 1, then go back to what state? Amount dispatch state. Dispatch the amount. If amount is not yet dispatched, be in what state? Amount dispatch state. If amount is dispatched, go back to what state? Output logic 1 and go back to what? Reset state. So when we have bigger designs, first we write a state machine for that. In what state, what we have to do? In pin entering state, what we have to do? Wait till pin is entered. After pin is entered, compare whether it is a correct pin or not. If it is a correct pin, output logic 1. If it is wrong pin, output logic 0. If output is logic 1, go back to amount state. If output is logic 0, go back to reset state. That is what we have to do in pin entering state. In amount entering state, what we have to do? Check amount is entered or not. If amount is not entered for long time, go back output logic 0 and go back to what state? If amount entered is wrong, check for amount entered. If it is less than its balance, it's okay. If amount entered is in multiple of hundreds or 500, it's okay. If it is wrong, then you output logic 0, go back to what state? Reset state. If it's correct, output logic 1, go back to what state? Dispatch state. Check whether the entire currency is dispatched. After dispatching, the motor sensor will produce logic 1. Some light it will produce. Check for that. So after dispatching, produce logic 1 and go back to what state? It is not a dispatch, be in the dispatch state. This is how the bigger designs we will write the finite state machine. Then for this finite state machine, we will start writing the Verilog code. What is the benefit of using Verilog or VHDL? I've already told you, we can describe any circuits based on the behavior, not on the structure. I give you an example, right? Try to implement mux by using its basic gates. It's difficult, but implement by using its behavior, it's very easy. That is a benefit of RTL. So we are not going to discuss about RTL because it's a front end. Yesterday we had demo for front end RTL. How to write the RTL, everything we will discuss in the front end. So I can just discuss in ASIC flow. ASIC flow, we can just discuss that we represent Verilog or VHDL to describe any circuits by using what? Behavioral. So this is an example of 4:1 mux. Whether you have select line, right? If select line is 0, 0, output will take what? A. If it is 0, 1, output will take B. So just use case statements and write it, right? If S0 and S1 is 0, 0, A will take what? Output will take A. If it is 0, 1, it will take what? B. 1, 0, it will take what? C. 1, 1, it will take what? D. So only you have represented the mux by its behavior, not by its internal structure. That is the advantage of what? Here, RTL code. So now the design is in what form? Design is in, I can tell it is in a behavioral form, right? Design is in the behavioral form. We are only representing the behavior of a circuit. Now, for each block, write the RTL code like this. Here, for each block, write the RTL code. After writing RTL code, you can verify whether this RTL code is working proper or not. That is called as what? RTL verification. It is called as RTL verification, functional verification, or design verification. Anything we can use RTL verification, functional verification, or design verification. What is RTL verification? Verifying functionality of a design. Whatever the RTL code we have written earlier, you verify whether this RTL code is correct or not. How do you verify? For your RTL code, you have apply the inputs, right? And check what is the output. In the same example, if you take where you have I0, I1, select line S, and output what? Y. So if I will apply this combination of input, what is the output? If my select line is 0, Y will take what? I0. So what is I0? 0. So 1, 1, 1. Select line is 1, Y will take what? I1. What is value of I1? 1. 0, 1, 1. Select line is 1, Y will take what? I1. So what is value of I1? 1. So this is called as test case. What is this called as? Test case. Each input is called as what? apply different test case and verify what is the output. If you are getting intended output, then your RTL code is correct, or else you have to modify your RTL code. So what is RTL verification? Verifying functionality of a design by applying different test cases. That is called as RTL verification. Again, that is a separate course. I have given the example of simple design. For bigger designs, we cannot verify very easily. There are rules and regulations to be followed. That is called as UVM. What are the rules should be followed while doing the verification? That is called as what? UVM, Universal Verification Methodology. And to become a RTL verification engineer, you should be knowing Verilog, System Verilog, and UVM. Then you can become RTL verification engineer. These are test code. In test code, I am applying different inputs. For select line, I am changing continuously. What is select line first? 0, 0. After 10 nanoseconds, modify select line to what? 0, 1. This hash 10 indicates after 10 nanoseconds. After 10 nanoseconds, modify select line to what? 1, 0. After 10 nanoseconds, modify select line to 1, 1. After modifying select lines, after 10 nanoseconds, $finish means stop the simulation. This input, whatever mux example I have given, what is this input? A, B, C, D. What is the A, B, C, D value? 1, 0, 1, 0. I'm keeping it as constant. A is 1, B is 0, C is 1, D is 1. And select line I'm continuously modifying. So based on the select line, I will check what output I will get. Based on the select line, I will check what output I will get. If I'm getting intended output, so we will generate the waveforms like this. Through waveform, if you're getting intended output, no issues. If you're getting wrong values, then you have to modify our RTL code. So now, after RTL, see RTL verification is an intermediate step. Just verify the RTL. But my design is in what form? Now my design is in the BRL form. Next comes synthesis. What is synthesis? What is synthesis? Convert RTL into gate level netlist. See, RTL is in the BRL form. Convert that into what form? Gate level form. See here, RTL is written for different blocks. Right? RTL is written for what? Different blocks. So before coming to synthesis, there is a RTL integration engineer who will integrate all these blocks. Integrate means connect the blocks using Verilog, not by using metal layer. Using Verilog, you connect the blocks logically. After that, this entire RTL will come to what step? This entire RTL will come to what step? Synthesis. What is synthesis? Converting RTL to gate level. I'll tell you what is netlist later, but for time you can understand that convert RTL to gate level diagram. So in RTL, my design was in BRL form. Now convert into what form? Gate level form. So what are inputs for synthesis? If you want to do synthesis, what are the inputs? What are the inputs for synthesis? Can you tell me? See, one is your RTL, right? RTL, Verilog program should be there. That only I should convert to what? Gate level diagram. So here gate level diagram I have to convert. One is what? RTL. Second one is what?
Technology files. Mm.
See, you want to convert this RTL to gate level form. What gates you can use to convert? Whether you can use MUX, whether you can use AND gate, whether you can use D flip-flop, whether you can use RS flip-flop. So who is going to tell that? So you need gate level information, right? What gates you have to use for conversion. So that is given in a file called as liberty file, .lib. Liberty file is also called as what? Library file. So this library file has gate information. Gate information means what gates you can use for conversion. So in this file, you will be having timing information and power information of gates. Timing means delay. How much delay this gate will take after applying input. After what time I will get what output. That is called as delay. Delay and power. How much power this gate will consume. So timing and power information of gates is present in what dot lib. So your RTL, your synthesis tool will pick all the cells from dot lib to convert what RTL to gate level. And third, what is required? HDC constraints. HDC constraint stands for synopsis design constraints file. So what is HDC constraints consists of?
Clocks and generated clocks and virtual clocks.
Yes, correct, right? So first input is RTL. It is basically in what form? BRL form. Next input is Liberty file. Liberty file contains what timing and power information of standard cells. What do you mean by standard cells? So like basic gates like buffer, inverter, OR gate, AND gate, NAND gate, NOR, XR, full adder, half adder, D flip-flop, mux. So basically these gates are required to implement any circuits. Those circuits, for all these gates, what is the timing? Timing means cell delay. Power means you have three types of power. One is leakage, switching power, and short circuit power. That is static and dynamic. That information, all those things we'll discuss in CMOS. So power and the timing information of every cell will be present in .lib file. So third file is here HDC file, means it is having constraints, timing constraints. See, without constraints, synthesis is very easy. With constraints, it's very difficult. Means I'm telling, do the synthesis conversion from RTL to gate level by meeting these timing constraints. Timing constraints mainly has your clock period. Your design should work with what clock period? Clock period means it's a clock frequency, right? Time period is inversely proportional to what? Frequency. Mainly you have clock period. Within this clock period, you have to, your design should work. To verify that, we do setup analysis. What is it called as? So you will understand this in STA. What is setup analysis? And we have timing constraints like uncertainty, input delay, output delay. All those things we will understand when we do STA. Now you can understand only what is a clock period. Within this clock period, your design should work. Or clock frequency. You have to do synthesis in such a way that your design should be satisfied with for this clock frequency. That is a timing constraint. See, timing without constraint is very easy, but with constraint it is difficult. Like you yourself put a constraint, right? I should go and come back to VLSI Guru with 10 rupees. It is difficult. You have to take a bus, come, go back. But if there is no constraint, go and come back whatever modes you want. Book a cab, come here, book a cab, go back. It's very easy. So with constraints, synthesis is very difficult. So the constraint, timing constraints is given by HTC file, means your design should work within this frequency of clock. So whether it is working or not, to verify that, we will do setup analysis that you will learn later. So these three important files are required for synthesis. What is output of synthesis? Gate level netlist. What is gate level netlist? See, gate level netlist is also a Verilog file. Right? Gate level netlist is also a Verilog file. RTL is also a Verilog file. So, but RTL you can use any syntax of Verilog, like if statements, case, anything, right? But gate level netlist should have only gate and its connection. No assign statements, no if statements, no case statements, no procedural statements. Only you should use gate and its connections. That's it. So I have example for
Right.
netlist. Yes, please tell me.
Like mapped Verilog file.
Yes, I have example for netlist here. I'll show you. Just give me 1 second. I'll come back. Drink water and I'll come back. Yes, sorry for the delay. Now, what is gate level netlist? I have an example for that gate level netlist. So here there is a connection of two blocks. This is one block. This is block one. I told you, right? Your entire chip is connection of what? Your entire chip is connection of different blocks. This is different blocks. So this is one block. This second block. So similarly here, after synthesis, I have gate level diagram. In this is first block. Right? This is first block. This is block one. So first we will. This is your full chip. Right? This is the full chip. This entire chip has what inputs? A, B, C. These are the inputs. What is the output? Y. So this full chip has two blocks inside. What is the first block? B1. What is the second block? B2. Two blocks I have inside. So first we will write the Verilog code only for one block. Means I will show gate level at least for one block. This is one block. Now this block is connecting to what? What are the inputs for this block? B1 block. If you take this B1 block, what is the inputs? M, N, O. What is the output? P.
P.
First we write the Verilog program for this one block. Right. That is gate level netlist. This is a gate level netlist for the block. Right. So I hope everyone know Verilog here. If you are not knowing Verilog, then we'll cover in the basics. Right. So module temp1. So temp1 can be any name. This block name is what? Temp1. Just we are using word temp1 here. And what are the inputs for this? M, N, O, and what is the output? B. So these are called as ports. What we call ports. Input and output of a block is called as what? Ports. Here M and O are ports and P is a port. Input and output of a cell is called as what? Pins. This we called as what? Input and output of a cell. Cell is another name for gates. So A, B, Y is called as what? Pins. So now input is M and O. What is output? Output of block is what? P. And I have two intermediate wires here. Right? What are the intermediate wires? N1 and N2. Two intermediate wires I have. Now I have first. This is called as gate level description. Right? First I have first AND gate. Right? This AND2. AND2 is a name of AND gate in the Liberty file. I've already told you we have a Liberty file. What is Liberty file? This Liberty file. So in this Liberty file, what is the name of AND gate? AND2. AND2 indicates two input AND gate. If AND gate was having three input, what will be the name? So name may not be the same. It can be any name. What name present in the Liberty file? The same name is used here. AND2. Next I have U1. What is U1? U1 is an instance name. What is this called as? Instance name. Means in the design I can have n number of AND gates. For one AND gate to another AND gate, there should be name difference. So for that reason, this U1 is added by my synthesis tool. For every cell, this instance name is different, U1. This is the instance name, U1 is. Next, this is port mapping. This is called as what? Means this A pin of my AND gate is connecting where? M port. You can see here dot A of M. Means A pin is connecting to what port? So B pin, where it's connecting? So B is connecting to N. And Y, where it is connecting? Y is connecting to net N1. Net means it's a wire, piece of wire. But we call it as net. So Y is connecting to net N1. Done. Description of first gate is done. Similarly, second gate. What is second gate? R2. What is U2? It's an instance name. My synthesis tool will give instance name for every cell. Separate name. U1, U2, U3. If I have 10,000 gates like this, I will be having U 10,000. Right? So now A pin, where it is connecting? A pin is connecting to net N1. B, where it is connecting? Port O. And Y pin, where it is connecting? It's connecting to net N2. So this is called as net N2. This wire. This is called as net N2. That is what you can see here. A is connecting to net N1. Right? B is connecting to what net? Sorry, port O. Y is connecting to net N2. Last is inverter. Inverter, what is the instance name? U3. Where A is connecting to net N2. B is connecting to port P. Right? That's input. Inverter has only 2 pins. Now, this is called as gate level netlist. For one block we have written, right? This is called as what? Gate level netlist. It is not having any assigned statement. It is not having any case or if. It's having gate and its connections. Only should be having gate and its connections in the netlist. No other syntax. So similarly, if I write for this block, second block, for second block I have secondary block code. So here, this is U4. What is this? U4. It is an AND gate. All right. Here it should be also and just one second. This should be also AND 2. I can read it now. Okay. So this AND gate, A pin, where it is connecting? It's connecting to where it's connecting? It's connecting to Q. B pin, where it's connecting? It's connecting to port R. And Y, where it's connecting? It's connecting to net N1. Next, I have inverter, this second inverter. A pin, where it's connecting? Net N1, and Y pin, where it's connecting? Port S. So now this second block we have discussed. Second block, I have what? Gate level netlist. Now this block and this block we have to integrate, right? This block and this block we have to what? Integrate. So for that reason, I have final RTL code. This is a final RTL code. What's the final RTL code name? Top. So what are the inputs for my final RTL for full chip? What is that? A, B, C. That is what we can see. And what is the output? Y. So input and outputs has been declared. So what is net N1? It's an intermediate net. You can see this net. That is connecting from one block to another block. Now temp T1. Temp T1 is nothing but this module I am calling here, right? This module is called here, correct? What is temp T1? This is the module name. First block module name. For first block module name, what is the inputs for first this temp 1? M and OP. For M, what is the input we are passing? M is connecting where? A. That is what's shown here. N is connecting where? B. Right? You can see N is connecting to B. And O is connecting to C. And P is connecting to what? Net N1. Next, temp 2, where it is connecting? Your Q is connecting to what? Net N1. and R is connecting to net N2. Actually, there is no net N2. That is thing that is a mistake, right? R is not connecting to net N2. That is a mistake there. And where S is connecting? S is connecting to Y. So we are integrating two blocks. Output of P. What is P? P is connecting to what? Net N1. So P is output of what? Block 1. But net N1 is connecting to what? Q. What is Q? Q is input of block 2. So block 1 and block 2 is connected by using what? Net N1. So two blocks has been integrated. This is called as RTL. So here each block is having how many cells? 1, 2, 3. Second block is having how many cells? But in reality, each block will be having lakhs of cells. Millions of cells. 1 million is equal to what? 10 lakhs. You will be having 30 lakh cells in one block. Like this, I have declared 3 cells, right? You will be seeing 30 lakh cells in real designs. Here I have two blocks. Two blocks has been what? Integrated now. Yes, you got it. What is gate level netlist? So you can see temp1 and temp2 are the two blocks. Temp1 and temp2, they are integrated here. So in the gate level netlist, we have only gate and its connections, right? So you can see only gates here. In this block, this is integration of blocks. So this is what is this inside block? If you see, you have what? Only inside block, you have what? Only gates. You can see also connections also, right? So what is output of AND gate? This Y. Y is connecting to what net? N1. You can see here Y is connecting to what net? N1. But what is input of U2? That is what? A. A is also connecting to what? N1. You can see here. AND gate output is connecting to net 1. AND gate output is connecting to net N1. OR gate output is connecting to OR gate input is connecting to what? Net N1. This indicates what? There is a connection between output of AND gate to input of OR gate. This diagram itself is not required. Only if you give this netlist, my tool can understand the connection. Right? Output of AND gate is connecting to net N1. Input of OR gate is connecting to what? Net N1. This clearly indicates there is a connection between output of AND gate to input of OR gate. There is a connection here. Similarly, here also, output of OR gate is connecting to what? Net N2. Input of inverter is connecting to net N2. The meaning is what? Output of OR gate is connecting to input of inverter. So this is called as gate and its connections. We will not give this schematic. We will give this netlist. My tool can understand the connection between gates and modules or blocks. So here, what is output of first block? P. P is connecting to what? N1. And what is the input of second block? Q. Q is connecting to what? Net N1. This clearly indicates that output of first block is connecting to what? Input of second block. So they have connections. So here you can see gate and its connections. Here you can see block and its connections. Simple example. So this is the gate level netlist of the chip. Simple example. But in the real design, instead of 3 cells, you will be having how many cells? 20 of cells. Next, after synthesis, now in RTL, design was in the behavioral form. In synthesis, we converted to what form? Gate level form, which my foundry can understand. My foundry can understand only the layout level. Now the role of physical design engineer comes. The role of physical design engineers is convert this gate level to what? Physical level. Physical level means layout level. So after synthesis, there is a next team comes into picture that is called as DFT. Design for testability. Whatever netlist we have, right? This netlist, modify the netlist so that the chip can be tested after fabrication. Whatever chip we have, See, transistors are not integrated. Transistors are inside the cell. How, sir? How billions of transistors are integrated with each other? Can have some demo diagram, right? That is what the layout, right? So fabrication, we will do it in CMOS. How it is done? Here I have 3 cells, right? Similarly, I will be having thousands of cells in the netlist, lakhs of cells in the netlist. Fabrication, how they will integrate, it is in the nano level, right? No one will knowing how the fabrication done. If I know, you know the fabrication, how they are doing, every country will be having a fabrication unit. How they are doing fabrication in nanoscale, only we will be knowing the concept, how they will do fabrication. Like they will do etching, they will do oxidation. Concept for educational purpose, they'll be knowing. But how they will integrate, what are the process they will use, no one will be knowing. So that is depends upon what machineries they use. But concept of fabrication, how the fabrication is done, so those things are discussed during the CMOS basics. So now before going to the physical design, there one team comes into picture. What is it called as? DFT, design for. I have to test the chip. Testing chip happens after fabrication. The chip is fabricated now. We have to test the chip. Apply some input. Verify output. Whether I am getting proper output, then the chip is working properly. So during fabrication, we are not sure that chip is fabricated properly because this is the metal layer, right? This is the actual metal layer. 2 metal layers are like this. But during fabrication is chemical driven process. Means to form the metal layer, they are not going to grind. They will remove the metal layer by using what? Acids. So while fabrication, the metal layer can be formed like this. Not every time, some of the times, right? Without our notice or without the notice of foundry, metals are shorted here. 2 metals are shorted here, but actually they should not short. But during the fabrication, in some ICs it will be shorted, in some ICs it will not be shorted. Even foundry cannot identify. See this previous example here, there is a mistake, right? In place of R should get input from some other block, right? It may get in output of what? If I have third block, output of some other block may connect to what? R. Or this only is producing any other output. This block only is producing any other output that can be connected to R. So here R is left as it is because that can be output of some other block. If I have third block and third block, that can be the input. Just we have taken example to show what is the netlist. If third block is there, then I should be having definition for what? Third block, and that will be taken here, right? Temp3, and that connection I should represent. So DFT, right? So chip is fabricated, and after that I have to verify the chip. So if whatever input I apply, whether I'm getting the proper output, then the chip is fabricated properly. Then use the chip. If whatever input I apply, I'm getting non-proper outputs, then throw the chip. Chip is of no use because internally it has shorted. Internally somewhere the fabrication has gone wrong. The metal is fabricated like this. Internally metal layers are shorted. So there are millions of metals inside a chip which they cannot identify where there is a short. They can identify only by passing the inputs and verifying the outputs. So to facilitate this operation, applying the inputs and verifying the outputs, what DFT team will do, they will modify the netlist. They will modify the netlist while designing only, not after fabrication. While designing only, as soon as they get the netlist from the synthesis team, they will modify the netlist without affecting the functionality. They will insert some scan chain, like some D flip-flops here and there. They will insert. They'll insert a scan chain. They little bit modify the netlist, so that why they will modify the netlist, so that chips are tested after fabrication. Chips can be easily tested after fabrication. So little bit they will modify the netlist. So how to do the modification? What are the steps? So again, TFT is a separate course. That is not part of physical design. So in DFT, you will get a scan chain insertion, MBEST, ATPG, automatic test pattern generation, boundary scan. You will get different steps. So major steps are scan chain insertion, MBEST, automatic test pattern generation, ATPG. Next is boundary scan. So these things you will learn in DFT. So as physical design point of view, as soon as we get the netlist, directly we will not get to the physical design team. It will go to what? DFT. They will little bit modify the netlist, but functionality remains same. Here and there they will use a D flip-flop. Right? Here they will add one D flip-flop. In between here, one D flip-flop they will add. Here they will add D flip-flop. After every few cells, they will add one D flip-flop, so that they can easily test the chip. So that is called a scan chain insertion. So after modifying, after DFT modifying the netlist will come to what? The netlist will come to physical design. Now the role of physical design is, in the netlist we have gate level design. Convert that to what? Convert that to layout level. So here every transistor should be replaced with what? Here every transistor should be replaced with layout. This connection, whatever you're seeing, this should be replaced with what? Metal layers. So that is the process what physical design engineers do. So what is physical design? Convert gate level description into physical level. So physical level for gate, what is physical level? Physical level is layout. For net, what is physical level? Physical level is metal. Right? This connections you do. After that, you generate the GDS file. Then you send to what? Boundary. So what we will do it in physical design. Right? We will take a break now for 10 minutes. We will continue after the break. So take a break till now. Time is 11:15. Take 10 minutes break till 11:25. We'll continue at 11:25. In that, we will see what we will do it in physical design. After seeing steps in physical design, we'll discuss about our syllabus coverage. After syllabus coverage, your queries, if you have still queries, you can discuss. Then we'll wind up. Take 10 minutes break and come back. You have restroom here. Now, what is the first step in physical design? Partitioning. Means we cannot do physical design for entire chip. So each chip has, this is the entire chip, right? This is the entire chip. So this chip has almost equivalent to how many cells? We can see every term in VLSI, we terms the cell count is represented in millions. So we have 30 to 40 millions of cells, which is equal to 3 to 4 crores. So we cannot directly do the physical design. Doing physical design is very, very difficult because tool will crash out. So we will do physical design for only one block. Now, first step in physical design starts with same, right? Divide this entire chip. Divide this entire chip into blocks. This one. Like this. It is not the area based division, it's a module based division. What is the meaning of module based division? I think I have shared the screen. I am resharing the screen. Whether the screen is visible to online students? I am in partitioning
Yes.
slide. Whether the same slide is visible, partitioning slide? Yes, thank you. So now it is module wise division. Module wise means estimate what is the area required for this entire complete module. So I cannot divide this full chip into different halves, right? What is the complete area required for this complete module? What is the area requirement for this complete module, right? So you can see this first module is having how many cells? 3 cells. Second module is having only 2 cells. So second module requires less area. First module requires more area. Like for each module, how much area is required? Based on that, you divide the chip. It is not that you have a chip and divide into equal halves. Not like that. It's not a area-wise division. It is a module-wise division. So probably the net list of A may be having more cells. It is having more area. Net list of C is having less cells. It's having less area. So this A is one block, B is one block, C is one block, D, E, F, right? So this is called as blocks. See, physical design, integrating all the blocks is called as full chip level design. Right? What is called as full chip level design, or it's also called as top level design. It's called as full chip or top level. So top level and full chip, very less engineers are required. In one project, you require hardly 4 or 5 engineers. But to do the physical design of block level, right, you require more engineers. One full chip, if you divide to number of blocks, it will go to 60 to 70 blocks. One full chip may have how many blocks? So almost you require 30 to 40 engineers for one chip. Because if one person is having 2 blocks, then hardly he may require almost how much? One person is handling 2 blocks, then we may require almost 30 to 40 engineers for one complete chip to do the block level physical design. So here physical design is 2 types. One is full chip physical design. What is role of full chip physical design? Take all the blocks, integrate, test, and send it to foundry. Next is what? Full chip block level, right? This is only one block. Block level physical design. So here we mainly focus on block level physical design because there is more opportunities for block level compared to what full chip. Full chip, you will be moved to full chip only if you are having experience 5 years, 6 years, or 7 years. Till now, till then, you will be working with what level? Block level. So for each block, we will discuss. We have all these steps. What is that? I am not discussing about full chip. I am discussing only about block level physical design. For each block, we will be having this floor planning, placement, clock tree synthesis, routing, and sign up checks. See, for each block, for A block, B block, they will be having their separate netlist like this, right? This is a netlist for which block? Temp1. This is a netlist for which block? Temp2. Similarly, for each block, we will be having separate netlist. That netlist will be given to each person. So in temp1, how many cells we have? 1, 2, 3. In temp2, you have how many cells? 1, 2. So similarly, each person will be knowing his cell count. What is the block level cell count? Now we will discuss about block level physical design. So if you get the block level, each block, the shape may be different. Any shape you may get, right? You may get L shape, you may get inverted L shape, you may get square shape, you may get U shape, some other shape you may get. So in block level physical design, I already mentioned we have these many steps. What is that? Floor plan, placement, clock tree synthesis, routing, and sign off checks. What is first thing? Floor planning. This is floor planning. Floor planning has these many steps again. Creating core area and die area. So you should create your core area and die area, right? This is core area based on the shape of your block. This is core area. And outside thing is your die area. So inside boundary is called as core area. Outside boundary is called as die area. You cannot create whatever area you want. You should create the area in such a way that it should accommodate all the cells. See, what is your ultimate role? Inside this core area and die area, place the layout of cells. Take the layout of each cell. Place what? Layout of cells. What you're placing inside this? Layout of cells. You are not going to draw the layout of cells. For AND gate, OR gate, NOT gate, whatever gates you are using in your netlist, for all these gates, whatever gates we have here, AND gate, OR gate, inverter, for all these gates, for all these standard cells, right? These standard cells. For all these standard cells, the layout is already drawn from layout team. That is full custom team, that is separate team. They will draw the layout and they will give you in a file called as left file. What is the file name? Left stands for library exchange format. In that left file, you will be having the layout of cells. You are not going to draw the layout. Already the layout which is already present, that layout you are going to directly place inside the core area. That is done in a step called as placement step. But in the floor plan step, what you will create first? Core area and die area. This core area should be created in such a way that it should accommodate all the cells. Layout of all the cells without overlapping. I cannot create less area or I cannot create very huge area. So create an area in such a way that it's going to occupy all these cells. Means if I'm creating the core area for temp1 means I should create in such a way that I should occupy layout of what? AND gate, OR gate and inverter. Next, what is the next step? Next step is port placement. What are ports? Inputs and outputs of a block, right? What is port for temp1? M, N, O. What is port for what is output port? P. What is port for temp2 block? Q, R and Y. So here we have 3 input ports and 1 output port for temp1. But in reality, we will be having 200 to 300 ports in real designs, right? So what are the ports you have? You place the port, you do the port placement in between core area and die area. Here, right, do the port placement. Place the ports. Ports means here piece of metal layers. What are ports here? Piece of metal layers. So that's it. Right? In any signal will come to this port first. From the port will come to your cells. All these are input ports. All these are output ports. See, you cannot place the ports wherever you want. You should place the ports in such a way that it is satisfying your full chip requirement. Right? The meaning is, what is the meaning of that? For example, you have block A core area and die area is like this. Right? I want to place the ports of block A. See, all the inputs for block A is coming from C. Then where I have to place input ports? Here I have to place the input ports, because output of block C is directly coming to input of what? Block A. So they can directly do the connections. So all the input ports I have to place here for block A. Output of block A will go to what? Block B. Then all the output ports of block A should place on what side? Right hand side. So like that, seeing the communication between the blocks in full chip. So where input ports I have to place, where output ports I have to place, we have to decide. It's not blindly I can place wherever I want. It's not like that. Decide where I have to place. So, okay, output ports of all the outputs of block A is going to block B, then place output ports here. And input ports of block B, where you will place? Here, right? And full chip engineer will connect these ports. And these ports are coming from where? Block A. So the connection happens like this. Right? That is called as port placement. So what is port placement? What are ports? Input and output of a block. Input and output of a block is called as ports. So next step is place the ports like this. What is next step? So we will discuss all those things. How to place the ports. What are different commands to place the ports? What are different methods to place the ports? Next is macro placement. Place the macros. What are macros? First question. What are macros? Macros are layout of some complex cells which are already designed and optimized. See, from complex cells which are regularly used, those cells are already designed and layout is already available. You need not to write the Verilog code and you need to do the synthesis for that. Which is already readily available, use it, right? Directly use the layout in your design. Just I want to see you, for example, you are preparing some meals in your home for festival. You assume you are preparing some meals for festival. You are creating everything from the scratch. You want to create some puliogre. So puliogre mix is readily available in what? Shops. So puliogre mix you will not create from readily from the scratch. Directly purchase from the shop, directly mix with water. Rice. Because why you are purchasing from the shop directly? Because that puliogre mix is readily available in the market. It will save your time. First thing. Second thing, it is guaranteed that you will not meet that taste. If you can create more better taste than that, then what you will do, you will create from the scratch. You will do from the beginning. But if you feel that okay, I cannot whatever I am doing from that I cannot beat the taste, then what you will do, directly bring from thing, right, and mix it with your rice. So similarly, for any designs from the previous project, if the layout is already available, directly use, for example, SRAM. Right? I want to use in every project we use SRAMs. What is full form of SRAM? Static RAM. So for static RAM, I have to write the Verilog code. I have to do synthesis. And after writing synthesis, I have to do what? Physical design. So SRAM will be implemented by using basic gates. But for SRAM, the layout is already available. then directly use the layout of what? SRAM. So macros are designs which are already designed and optimized. Optimized means improved for the performance. Performance is improved, right? So if that type of designs are available, directly use it and place inside the core area. So place the macros if you have it. Right? So macros are big in size. Layout. This is layout of macros. If you have layout of macros, place that. I have macros I have placed. So first we will do macro placement. We will not do standard cell placement. Why? Because macros are very less in number. Right? Macros are very less in number. Hardly it will vary from 10 to 100, within 100. But what is the standard cell count? It will be in millions. So layout of macros you place if you have anything. Right? That is called as macro placement. What are macros? Design which is already designed and optimized. Layout is readily available. If layout is available, directly you place it. So what is the benefit? Writing the Verilog code for this, doing the synthesis for this SRAMs, that is saving my time. Then after macro placement, next we have what? Power planning. So power planning is very important step because if you see the layout here, right, at the beginning I have shown the layout. Every cell requires what? If you see this layout, every cell requires what? VDD and VSS connections. So for all the millions of cells, what I am placing here inside my core area, I will place it in the placement stage. They require VDD and VSS connections. Even macro requires VDD and VSS connections. How to do better power planning? So that I am not having any IR drop. What is IR drop? For example, I have one VDD port here. You assume that VDD port is present here. I have one cell here. This cell is getting VDD from here to here by using metal layer. This metal layer, right? This VDD is, you assume it is 1.5 volts. What is the voltage? 1.5. This is the voltage value VDD. See, VDD will be like 1.5 volts or it will be like 0.75 volts. It will be not like 5 volts or 12 volts like your textbooks. Because your textbooks is discussing with the older technologies. But when we go to lower technologies, the VDD value will be also scaling down. It will be in 1.5 volts or 0.75 volts. Right? So now I have 1.5 volts here. What voltage will reach to my cell? Whether 1.5 volt will reach to my cell? No. After out of 1.5 volts, only 1.2 volts will reach to my cell. 0.3 volts is dropped on what? Metal layer. Because metal layer will conduct current. What is that? I. Metal layer has resistance. What is that? R. I into R will become what? Voltage V according to Ohm's law. So out of 1.5 volts, 0.3 volts will drop on what? Metal layer, and that will convert into form of heat. That voltage is converting into form of what? Heat. Because as you know, law of conservation of energy. Energy neither be created nor be destroyed. It can be converted to one form to another form. So your voltage energy is converted to heat energy. And remaining 1.2 volts will reach to what? Cell. So this will decrease the cell performance. Means cell delay will increase. If voltage decreases, cell delay will what? Increase. So you will see this relationship in CMOS. How if voltage decreases, cell delay will increase. So my VDD was 1.5, but at the cell, how much it is reaching? 1.2 because remaining 0.3 is dropping on what? Metal layer. So this is called as IR drop. What is this called as? IR drop. But wasting this much voltage is wasted out. That is converted to heat. So how to avoid this IR drop? So how to do better power planning, that we will discuss. So we have to create the rails, we have to create the straps. From the straps we have to connect to the rails, right? All those terminologies I cannot discuss now. So we will discuss how to create the better power planning so that all cells will get the power with what? Less IR drop. How to do that? So these are the major steps. Even we have physical cell placement, but these are the major steps in what? Floor planning is the first step. What are the steps? Create core area, die area. Next is what? Port placement. Place the input and output ports. Next is macro placement. Place these macros. Next is power planning. After that, next step is what? Placement. What is placement? Inside core area and die area, start placing the standard cells. Start placing the standard cells. Standard cell size is very less. We can start placing the standard cells. So what is the count of standard cells? It will be in real designs. It may vary from 1 lakh to 30 lakhs. It will not reach more than 30. Rare case it is more than 30. Place the standard cells like this. So all these are standard cells. So we are placing layout of standard cells. What we are placing? Layout of standard cells. After doing placement of cells, our role is not completed. We have to do n number of checks like congestion check, timing check, max cap, max trans, max fan out checks. If it is violating, we have to fix it. So if I now explain also, you will not understand because as you doesn't know STA, static timing analysis. So after placement, we have all these checks: congestion, timing. Timing includes setup check, max capacitance, max transition, and max fan out check. So these 4 checks we have to do. If this check is passing, then we can go to next stage. What is placement? Place all the layout of standard cells inside what? Core area. Inside core area. Die area is outside the core area. Place layout of standard cells inside the core area. That is called as placement. After that, we have n number of checks to be done. If this check is passing, then we can go with next step. Next is CTS, clock tree synthesis. Now build the clock tree, right? When the clock tree is not built, here you can see in the example, one clock port is connecting to what? All the flip-flops. What are all these things? All are flip-flops. One clock port will be connecting to all the flip-flops. Here load becomes very high. If load becomes very high, what happens? This is the actual clock. What is this? Logic high. Logic high means this capacitor should be fully charged. That is called as what? Logic 1. What is logic 0? Capacitor should be fully discharged. That is called as logic 0. And this capacitance value is very high because this port is connecting to all the flip-flops. So this capacitance is found by this cell pin capacitance. Every cell will be having pin capacitance and net capacitance. Net capacitance means metal layer capacitance. The net capacitance plus pin capacitance will form the load capacitance. So every cell net capacitance plus pin capacitance will form what? Load capacitance for the port. This has to be completely charged and completely discharged. So to become logic 1, it has to completely charge. In the process of completely charging, it will take shape like this. Completely discharging, it will take completely shape like this. Now, clock shape itself is lost. Why it is lost? Because it is taking more time to charge and more time to discharge, because capacitance is very big here now, because one clock port is connecting to all the flip-flops. Now because of that reason, what you do, you split the load on the clock port. How do you split? This clock port you connect to only one buffer, right? So now this port is connecting to what? Only one buffer. Now load is reduced. This port is having load of what? Only one buffer. And now this buffer you connect to these two buffers. And this buffer you connect to these two buffers. And this buffer you connect to these two buffers.
Sir, what is buffer, sir?
Yes, please tell me, what is your doubt?
Sir, what is that buffer?
Buffer is nothing but a cell where input is equal to output, just to break the net length, right? It is a cell where input is equal to what? Output. See,
Okay,
what
sir.
is the role of buffer? You'll understand when we do the physical design, right? So when you are doing, see, when you have flip-flops like this, right? Now what you will do, you will build a tree. How do you build a tree? You have a port. From the port, use one buffer. From this, use one buffer here. Now use one buffer here. Buffer is nothing but a cell which is having input is equal to what? Output. If at the input you have logic 1, output also is what? Logic 1. If input is logic 0, output is also logic 0. So here use one buffer, use here one buffer. Now you have built a tree. So now this buffer will connect to these two cells and these two cells. And this buffer will connect to these two cells and these two cells. Now this buffer is connecting to these two cells and these two cells. And this buffer is connecting to these two cells and these two cells. You're distributing the load now. Now earlier one port was connecting to all the flip-flops. Now this port is connecting to what? Only one buffer. And this buffer is connecting to only these two buffers. And this buffer is connecting to only these two buffers. Means this buffer is connecting to how many buffers? 1, 2, 3, 4. And this buffer is connecting to how many flip-flops? 1, 2, 3, 4. Like this, build a tree. If you build a tree, what happens? Then your clock will not degrade like that. So clock will become high. You will be having logic 1. Clock will become 0. You will get logic 0. Now shape is improved, right? Like this. Earlier, only one port was driving all the flip-flops. As because of that load was very high. For that reason, it was taking more time to charge and more time to what? Discharge. So the clock shape itself is lost. Now you will get correct clock shape. So we have to build a clock tree like this. This is called as H tree, right? It's like a hedge, correct? If you see the structure, this blue line, if you see how it is, it's like a H. It's called as H tree. So in CTS, you will understand why we have to build a clock tree. What happens if we are not building clock tree? How to build clock tree, right? How to build clock tree? What are the commands to build clock tree? What are the checks after building clock tree? We have to do checks like latency check, skew check, setup check, hold check. So all these checks we have to do. So these checks you will understand only if you do STA, static timing analysis. That itself is like almost a 15 days course. That we'll do. In our course we'll do STA. So if you understand that, then you can understand what checks we will do after STA, after CTS. So after CTS, if this check is passing, after clock tree is built properly, then you will go for what? Routing. What is routing? Routing is nothing but simply connect ports, macros and cells by using what? Metal layers. Right? Connect all the ports, macros and cells by using metal layers like this. Without shorts, connect it. So that is called as routing. So after routing, you have timing sign off checks. Sign off checks means before giving your block to the full chip level team, do this sign off checks. What are sign off checks? First time sign off check is what? Timing sign off. Timing should be met. Timing includes setup check, hold check. Means then you have checks like max trans, max cap, max fan out, right? So those are timing check you have to do. So timing check is done using separate tool called as what? Tempest and prime time. To do physical design, what tool we use? We will use Fusion compiler from Synopsys or innovus from cadence. But timing check is done by using separate tool again. Tempus or prime time. We will do timing sign off. Next, IR drop sign off. I already told, I have explained what is IR drop already, right? So how much IR drop is happening? In any cases, we have more IR drop. If we have IR drop, you have to fix the IR drop. To do IR drop check, we use separate tool called as what? Redox from synopsis, voltage from cadence. And third sign off includes what? Physical verification. That includes DRC, LVS. DRC stands for what? Design rule check. Design rule means Foundry has given the rules for us, right? Foundry has given the rules, means from one metal layer, if you draw, that should be of minimum width. The width should be minimum. You cannot reduce the width lesser than this, whatever Foundry has told. And between one metal layer to another metal layer, you should be having minimum spacing. You should not be having spacing lesser than this. So all those rules you have maintained or not, right? Those rules you will check. That is called as DRC. Next you have LVS. What is LVS? Layout versus schematic. What is layout versus schematic? This is layout. What is this? This is what is schematic? Your netlist is schematic, right? This is schematic. The netlist is schematic, and the physical design layout is layout. So here, A pin is connecting to what port? M port, and Y pin is connecting to what net? N1. The same connection is happening here or not in the layout. Right? You should check. Whatever connection happening in your netlist, the same connection is happening here or not by using metal layers. That verification is called as what? Layout versus schematic. If same connection is happening, no issues. If same connection is not happening, if any connection is left out, that is called as opens. If any unnecessary connection is happening, that is called as what? Shorts. You will verify that. Even that is fine. You will do all these three timing sign up. To do physical verification, we use IC validator from synopsis and PV from cadence. After this, we will send our block level design to what? Full chip level design. Full chip level design, he will integrate our block. He will create the GDS, and that GDS file is sent to what? Foundry for fabrication. Right? This is the total physical design steps what we have. So starting from floor plan, what are the steps? Floor plan, placement, CTS, routing, we have sign off checks. What are the tools? See, in this sign off checks, the sign off check is not part of physical design. That is separate team again. But we will do even sign off checks. In this sign off checks, only IR drop check is not done. I'm telling now only. Demo class only I'm telling. In the sign off checks, we will do what? Timing sign off. We will do what? But IR drop only theory is done, but tool wise we are not doing it. I am making, because that is a separate team again. Every team is separate team in industry, but here we don't have license for Redact, so we are not doing IR drop sign off. We are doing timing sign off and physical, but theory is done, but for the practical purpose only this is not done. IR drop. Apart from that, everything is done, from starting from floor plan to routing and sign off checks. Then what are the tools used? From synopsis and cadence. All right. For synthesis, layout is not that is a separate full custom design. For synthesis, what we use? Design compiler. From cadence, we use what? For physical design, we use Fusion compiler, and for cadence, we use Innovus. For SpecFX section, we use StarRC, and here we use QRC. For STA, we will use prime time. They use Tempus. Physical verification, we do what? ICV. Cadence, we use what? Physical verification system. ICV stands for IC validator. Power sign off, we use Redox. Cadence use what? Voltus. This power sign off I already mentioned. We are not doing by using what? Tool. Theory is done. And what we do in physical design, right? Sanity checks, floor planning, block level physical design, fancy checks, floor planning, power planning, pre-placement, placement, CTS, routing, sign off plus STA, static timing analysis. All these things we will cover in our physical design. And I think this core structure I already discussed, right? And one more thing I wanted to show you this syllabus also, what is done. So our course agenda, right? So all the things I have discussed, we'll do basics and all. Right? This is what the main thing we cover in our design. So I'll go into the deep of the. So this is what the project 1 and project 2. We have 2 projects. So one project is on 28 nm, another project is on 14. Only I'm discussing with synopsis. After synopsis, immediately we'll go to what? Cadence. That is separate project again. Right? This I'm showing only for synopsis. So these are the information. We have 52,000 cells. One more design has 1 lakh cells. Here number of macro is 40. In the second project, the macro count is what? 72. The total clock here is 5. Here it is 4. Here maximum operating frequency is 500 megahertz. Here it is 1 gigahertz. So one project is done with help of mentor. One project is allowed only you to do it separately. You can try one more project. So this is the shape of the block which is already implemented, L shape. These are all macros. This is the syllabus. First we'll start with what? Input files. What are different input files for physical design? Then we do what? Static timing analysis. What is setup check, hold check, what are types of clocks? What do you mean by latency skew? What is multi-cycle path, half-cycle path, asynchronous paths, like clock domain crossing and resets, asynchronous reset, how to handle it, the derate, what are different types of derate, PVT conditions, methods to fix the violations, how to do it. So next we discuss about physical aware synthesis and synthesis, right? All these things about physical aware synthesis and floor planning. Synthesis and floor planning we will do. Then we will do placement. I already discussed what is placement of cells. So types of placement, placement optimization. So while controlling the placement, how can we control the placement of cells? If I don't want to place cells in some region, then I can apply what? Blockage. Blockage indicates don't place the cells in that region. How to control the placement? We can control by using blockages, bounds, and magnet placement. So checks after placement. What are the checks after placement? You will do this congestion, max cap, max trans, max fan out, setup violation, right? We'll check. This is the block with macro placement. All these are macros. The small things what you're seeing is what? Cells. They are very small. If you zoom, you can see those cells. This is a congestion report. So wherever I'm seeing red colors, right? That is I have more congestion. Congestion means I have less routing tracks. Routing may be difficult in this region. After placement, I have to see whether I can route it or not. I can verify that. So these are all, I have violations here. Red color indicates that there is a congestion violation. I have to fix it. This is a congestion report. Next, we cover what? CTS. In CTS, we cover CTS specification file. What is non-default routing rules, clock buffers, target clock transition and latency, CTS exceptions, the different types of clocks like virtual clock and master clock and generated clocks, CTS steps, checks after CTS, like you will check max cap, max trans in clock path, latency skew, setup and hold violation, how to fix it, what is useful skew method, what do you mean by time borrowing, all those things are discussed. Next, routing. You will do the routing, connecting through metal layers. In routing, we will discuss about crosstalk, electron migration, and antenna effect. Those are the effect after routing. Crosstalk crosstalk will also affect my timing. How it affects? What is crosstalk glitch? What is the steps in routing? What is buffer on routes? How to fix DRC and LBS issues if we have. All those things are discussed. Next, this is the clock tree which is built. Schematic of clock tree. From the clock port, we have two buffers. Again, using all these white colors are called as what? Buffers. By using all this blue color called as what? Flip-flops. Here in one region, I don't have only one flip-flop. Here I have 500 of flip-flops. So this is how we are going to build clock. This is a clock tree, how the clock tree is built. This is the violation, routing violation, right? Here there is one metal layer going, another metal layer coming like this. Both are shorting each other. How to fix this routing? See here, there is a routing. If this region, if I zoom, I can see this. All this XX, red color XX indicates what? I have violations. How to fix those violations? How to zoom? How to check? How to fix the violations? So those things is checked after routing. After routing, we will do what? Sign off checks. Sign off checks. Red off and voltage is not used. Apart from that, we do what? Timing sign off and physical verification. Then, while doing the concept of physical design, we also use what? Advanced tickle. How to write the automation programs to fix issues. If you have 1,000 issues, fixing one by one will take a lot of time. How to write a script to fix all the issues at a time. So we have written many tickle programs. Some of the examples are here. Place the input ports. All the input ports you should place on what? This is core die area. This is what? Core area. In between die area and core area, you have to place all the input ports. You have to place with the 2 tracks distance. If you place one port here like this, after 2 tracks, 1 and 2 tracks, again you have to place what? One more port. After 1 and 2 tracks, you have to place what? Third port. After 1 and 2 tracks, you have to place what? Next port. So how to place the ports like this in between core area and die area? We have a script for them. This example tickle script, this tool command language, right? So like that, we have many automation scripts. So one is for port placement. Another one is for creating the voltage area. For multi-voltage design, we have to create the voltage area separately. Plan the voltage area, how to create this voltage area, right? We have the program for that. We have the program to create a ring around the macros. This power planning, right? During power planning, you have to create a VDD and VSS ring. You can see VSS and VDD ring around macros, and we have to make the connection to macro pins. So we have tickle program for that. So we have, this is the commands to fix the congestion. I show you the congestion, right? So how to fix congestion? We have tickle program. We have tickle program to identify which flip-flop is not having clock gating cell. See, clock gating is a method of reducing the power consumption. So which flip-flop is not having clock gating cell and what is the reason? To identify that, we have a program, tickle program. So this program is for useful skew method. So for useful skew method, we have tickle program for that. How to implement to fix setup violation, we use useful skew. What is the program? So these are the 6 simple examples, right? So this is the program to reroute the metals which is having shorts and opens. After LVS, we have shorts and opens, right? If you want to reroute, then this is a separate small program. And these are different programs to identify the slack through a cell, left side 5 micrometer, right side 5 micrometer. This is a tickle program we have. So we have some of the tickle programs. See, even though if I explain also you not understand, if you go through the course you'll understand. So this is the just examples what we have, and this is our whatever I have shown here. It is our course content. input files, STA, synthesis, placement. So we will cover CTS, routing, sign off checks, and advanced tickle. I'm not talking about basic tickle. Basic tickle is covered in what? Basics. Advanced tickle is done during what? During the advanced physical design. How to write the scripts for advanced to do some automation. So some of the examples I have shown. So this much is our course content. Right. So my demo is done. So I will take 5 minutes to answer your queries. So if you have any queries, this PPT will be shared. I'll share with the manager or the admin. He will share you in your group. If you are in the WhatsApp group, they will share you the PPT, this PPT, whatever course content we have. Alright. So apart from this, if you have any queries, you can ask them.
Sir, physical design have completed coding here, sir.
Yes, please repeat again. Once again, what is the doubt?
In physical design course, completed have coding or not, sir?
Yes, please repeat again. Please be a little bit louder.
Coding have or not, sir, in design course?
See, coding is not mandatory to do physical design. If you don't know coding, also you can survive in physical design. But if you know coding, you have better advantage of growing in the field, right? How do you grow in the field? In this field of physical design, if you know tickle coding, right? If you can automate the process, you are writing, say your chip top tells, say whatever ports you have, whatever you have, you place here on the top. Left side is not working out for me, place on the top. Then you take one port, place here, take one port, place here. You have 300 ports. If you do one by one, it will take what? How much time it will take? Instead of that, write a program. A program will push all these ports from here to what? Here. So if you know programming, it is better to you, and everyone will appreciate you. You can grow fast in your career. So tickle is must and should, you should know. And apart from the tickle, Perl and Python is optional. If you don't know also, it's fine. But tickles you should know compulsory. And tickle also, it is not that you should be knowing in complete how to write the program. Even without that, you can survive. If you know, it is good. Tickle, TCL, tool command language. First, we will cover that in basics. Basics of technical will cover. We'll first show you the syntax, how to write the if statements, how to write the while, how to write for loop. And based on those things, we'll do some example programs like factorial of a number, prime numbers. In the basics, we'll do that. In advance, we will use those syntax, how to do that. Right? So basics is covered for tickle. So we use tool command language. See, coding is not very depth. It's not like pages together. It is only micro coding. You can see here, right? In physical design, it's only we have lines for what? 24 lines. All are micro, small codes. It's not very big codes. Just to make process automated. That's it. If without coding also, you can survive in physical design. Yes, please tell me. Any other doubts?
Sir,
Yes, please tell me.
the process of this course is online or offline?
So what you're asking, cost of? See, this course, whatever course, the same fees for online and offline. You can attend any mode you want. It's left to you. One day you come for offline, one day you come for online. That's up to you. You can use any mode. How the course is happening now, in the same way the course happens for every class. Now candidates are attending online, even they are attending offline. Same way happens for every class. You can use any mode. See, if the strength is very big, like 70 to 80, we will divide the batches into 2 or 3. Okay? Yeah. But we will be having 35 to 40 candidates maximum in a batch, not more than that. So in that case, so one batch who are coming in, who are coming for offline, that will be morning. Who are attending online, that will be afternoon, or it may be combined of both. So now how you are attending, in the same way the course also happens, offline and online. We have other rooms, big rooms. In the big rooms we conduct offline as well as online. So course fees is same for both, and attending what mode you want, it is left to you. You can attend any mode you want. You can switch also.
Sir, while attending the labs online, how it will be?
You can attend the online. So same way screen will be shared. Mentor will type one command. They will give you ample amount
Okay.
of time to execute. And if you are not able to execute or if you're having any errors, there is session ID. For every candidate, if you open BNC, there is session ID. For example, your session ID is 29. If you tell your session ID, the mentor can open your screen. Mentor can open your screen here and he can guide you what to be done or he will help you. That he can do. Any candidate working
I
from home, if you tell your session ID, the mentor can open your screen and he can fix the issues.
Like tool download, how they will provide? Like we should come to Bangalore or we can
No, you
have
can attend
online.
online. Tool installation is
Okay.
also done online. Tool installation, while during the course, we will guide you how to do the tool installation. So
Okay.
you
It
can
will be
download.
done like after 2 months.
No,
Hello.
even during advanced course also, you can attend online. If you come to institute also well
Like
and good.
uh, yeah. Like
See,
downloading the tool, they will install after 1 month or 2 months. Like I'm asking.
during the basics, we will guide you with basic tools, right? How to install
Okay.
tools. During basics, we will guide you with basic tools. During advanced, before starting the advanced class, we will guide you to install the advanced tools.
Okay. Thank
If you have
sir,
capability of using advanced tools without help of mentor, you can install tomorrow itself. What is the point in installing, right? If I teach you installing advanced tools and if you don't know to use, then there is no point in installing. The installation is not very big process. It's half an hour process. Tool install, not even half an hour. It's 15 minutes process. So if you know to install the tools, you can install tomorrow itself. But as you people need a mentor support, so before starting the advanced classes, we will install the advanced tools. Before starting GVM, we will tell you to install GVM tools. Before starting Linux, we will install the Linux tools. So before starting every course, we will tell you how to install the tools. That is guided online also.
sir, I am doing job and I taking coaching, sir. Present, I am doing job, sir.
Yes, I am clearly mentioned. Like you can basics. Yes, please be silent for 2 minutes. Yes, I have already mentioned. Class timing is available for weekdays, Monday to Saturday, 3 hours. And we also have weekend only for the candidates who are working professionals. So you can opt for weekends. You can talk to the institute. You are not available in the weekdays. You can opt for weekends. First option. If you don't want to join for weekend also, then we will give you the recording videos. Live recording videos are given. You can go to the live recording videos. If you are missing, so I have opt for weekdays. I am available all the days, but in between 1 or 2 days I may miss. That is what your concern is. Then you can watch the recorded videos. Or if you don't want to opt for weekdays, then you can opt for weekends. So both are available for weekends, basics as well as advanced, right? Advanced weekend, there will be a theory session first. After theory session, there will be what? Lab for weekend candidates. Those who are opting for weekdays, lab happens from Monday to Thursday. So there will be no lab in the afternoon for weekdays candidates. So you can opt anything you want. For both, live recorded videos are given. You can utilize that if you are missing in between. So choice you should take where you are to join.
Sir, for e-learning mode, how a doubt will be solved?
See, e-learning basics also you have taken. See, e-learning physical advanced design, right? You will be allowed to attend the weekend labs. You can discuss all your doubts there. If you're aligning to this batch, PD advanced batch, if you're aligning to this batch, on request, we can allow you to attend weekend lab session. Only lab, not for theory, right? Weekend lab. You can attend, you can discuss all your doubts there. That is one option. Second option, if you are not attending this lab session, if you're not able to attend, then in your individual official WhatsApp group, you can ask any queries you have. And every 15 days once, you can ask for one-to-one session.
Okay.
See, for every student, there will be individual official WhatsApp group. No other student will be there. Only you will be there. Mentor will be there. Owner will be there. Manager will be there. You can ask whatever queries you have in their group, including the session queries, including the class. Everything you can ask in that group. And you need any support, you can request there. So one-to-one session will be done for the e-learning students for every 15 days if you want. We are ready, but you should be available for that to clarify all your doubts.
Sir, is laptop needed for even basics?
Yes, laptop is required because basics is 60% of basics is hands-on, right? GVM is hands-on, Linux is hands-on, Pickle is hands-on.
Okay.
Only CMOS and digital is, see, physical design basics is only for 1 or 2 days. CMOS and digital is only presentation type.
Okay.
So, but GVM, Linux, and Tickle is hands-on. You require laptop for.
Sir, like first 2.5 months, only 3 hours daily for weekdays,
It is not theory;
not
it
more
is
than that.
including hands-on. Right? If you come to GVM, Unix, and Tickle, it's hands-on.
Okay, like it is like lab also.
Yes. See, in GVM there are
Only
commands.
three.
We will
Yeah,
execute commands,
yeah.
and you will also execute commands. In Tickle, we will show you the syntax. We will ask you to do some basic programs. We will help you to do the basic programs. So that happens during the course of the time. Every day, three hours.
Okay. And after 2.5 months in advanced also, like 3 hours only.
Yes, Monday to Thursday, 3 hours. Right? It is Monday to Thursday, 3 hours for lab,
Okay.
and Saturday and Sunday, 3 hours for theory. So Friday is off.
Friday is off
So why Saturday and
when
Sunday?
we come to. Okay.
Because Saturday and Sunday theory is done by some expert lecturers who are also
Okay.
they're
In
not available on
advanced.
the weekdays.
Okay.
Yes, in advance.
Okay. Thank you.
This is the timing. If you are not
Oh, okay.
available on weekdays, then you can opt for weekend lab.
Okay.
Only if you are not available on weekdays.
Okay. Like it is same for online and offline. We should opt for them. Anyways.
Yes. Online, the same
Yeah.
way it happens. No, how it is happening, the
Yeah.
same way.
It is crystal clear. Like same. Okay.
Sir, weekend class, how much spent, sir?
The weekend depends upon the how many registers. Generally, we will be having from 5 to 15. It will may range from 5 to 15 weekend. Weekdays 30 to 40 per batch. That is what, right? Whatever we are doing for 4 days, we will cover in 2 days here because count is less here in weekend. But in weekdays, we have more count. So here we do 4 days, here we cover in 2 days because here we have to clarify the doubts for 30 to 40 students. Here we can clarify the doubts for only 10 students. So whatever topics done here for 4 days, the same thing can be covered in 2 days. So weekend strength may range from 5 to 15. It depends upon how many are opting. Based on. Okay, if you don't have any queries, so thank you everyone. So if you have any other queries, you can message in your WhatsApp, right? WhatsApp official number, you can message and get that clarified. Thank you everyone.
Sir, I have one doubt, sir.
Please tell me.
Sir, I am doing job, sir. Online coaching taking best or not, sir? Possibility or not, sir?
So can I ask you in which profession you are in?
Electrical maintenance, sir.
See, you can easily do, right? So only thing is you should be very active in handling it because of work pressure. If you miss one or two classes, so you should be cope up by using the recorded videos. So see, many of the candidates, working professionals compared to the freshers, right? They are in a good position. To be very frank, those who are switching the job, they are in a good position now. So we can do it. You can attend online. See, online, offline, both are same. It is not same thing happens. How it is happening now? You can attend through online also, but if you cannot attend during, you can opt for weekend, right? Then Saturday and Sunday, if you are free, you can opt for weekend. You can take the course.
Sir, weekdays best or weekend days best, sir?
According to me, weekdays is best.
Weekdays means regular, sir. Monday to Saturday.
Weekdays, see, lot of interaction happens. We have lot of students, lot of interaction, lot of doubts. So everything will be discussed. So weekdays is best. Weekend, less candidates, right? We have less candidates in the weekends, and that too happens on Saturday and Sunday only. Both are almost same, but according to me, weekdays is best. Both are almost same. There is no difference in placement support. Everything is same.
Sir, design verification course have completed coding, sir.
Yes, design verification is completely of system Verilog. It has coding, full coding. It is understand the concept of digital, implement it, understand the architecture or understand the protocols, and write the test benches for that. So it is coding. Design verification is not full of coding, but you have to understand the architecture. You have to understand the protocol, I2C communication protocol, understand Ethernet protocol. So after understanding, you should just now come up with a plan how to test it. Come up with a test plan. So test plan, for to implement a test plan, write the system Verilog code. So it is coding is there. 70% of coding is there. 30% is understanding and implementing.
I not have knowledge in coding, sir.
No, then you
Physical
can
design,
opt for either. See, I will tell you, either you can opt for physical design or you can opt for layout, custom layout. Layout is only drawing the layout. That is very easy. So either you can, if you don't have interest in coding, then either you can opt for physical design or you can opt for layout, custom layout.
sir, physical design have coding. What have skills needed?
So skills requirement is the same. What I have shown. You should be knowing CMOS. You should be knowing tickle, tool command. Little bit of coding we have. That coding is not to a lot. Means that coding is not to a level of BV, but little bit of coding is required. This is the requirement. See, we are doing the basics. Little bit of skills of coding is required. It's not to a full extensive coding. We are not doing it. Small amount of coding here and there will do. Even without coding, you can survive. No issues.
Sir, job opportunity, physical design is good. Design verification is good, sir. Job opportunity.
Both are same. Both are same.
Physical design
Both are
is
almost.
easy or difficult, sir?
See, everything is difficult when you don't focus. Everything is easy when you focus. That is what only I can tell. But compared to DV, when you're not interested in coding, physical design is best. That's what I can tell. See, physical design anyone can learn, but you should show the interest. See, today I have discussed some concept, DFT. You didn't understand anything. Go home, happily watch IPL, sleep. It will not give you anything, right? You should come back to the mentor, ask him, I didn't understand anything out of this. Please, can you explain once again? Or watch the recorded videos once again. Recorded videos anyhow they will upload, right? Watch it once again till you understand, right? So if you show this focus, anything is easy. So if you don't show the focus, you will lose the track. So if you don't understand today, tomorrow you will not understand anything, right? You lose the track. So show the focus. If you not understand, interact with the mentor. So how you are interacting now, right? The same interaction if you show during the lab session and during the theory session, you can easily learn the physical design. Physical design is not at all difficult. Anyone can learn. Even the person who is not doing, who is not part of electronics can learn the physical design. But you should show the interest. So anyhow, we are doing the basics, right? So you should focus more on the basics. Then you can easily learn the physical design. There is no doubt in learning physical design. See, two things you can easily learn. One is physical design and layout. Opt anyone.
Hello, sir.
Yes, please tell me.
Sir, actually, I am from April batch, sir. But I'm not able to enter the class. Then
You can
now,
rejoin. If you have
yes, sir.
paid the fees, you can rejoin to the next batch. Talk to the institute, they will allow you to rejoin to the next batch.
Is there any change in fees, sir? Fee payment?
No, if you have paid the full fees for the previous session, see, for example, I'll tell you one thing for every student. You have joined this batch.
Yes, sir.
After 15 days, you felt some problem, either in your family or your side, right? So you can tell to the institute, I don't want to continue now. I will rejoin to the next batch later. Then after the next batch, if you come, you can rejoin to the next batch. But you should have told earlier to us. I'll not
Yes,
continue, I'll rejoin. You have already taken the tool access for
yes,
already
sir.
3 months. Already you've taken the videos. And now again you want to rejoin means it is like extending the tool, right? It's equivalent to what?
Yes.
Extending the tool for next 3 months. If you would have told earlier to us that 15 days, after 15 days or 1 month, I don't want to continue because of some reasons, then we will stop your tool access. Then we will give you the tool access whenever you rejoin.
Okay.
So that tool, whatever you want to use, that extra fees you have to pay. The
Actually,
tool
I
is
have
very
completed.
costly.
Actually, I have completed 2 installments, sir, recently.
Which batch you were?
April, sir. April batch.
I think you can rejoin. You can talk to the institute. I think not an issue.
Yes. Thank you, sir.
Talk to the admin or manager tomorrow in the
Okay,
institute.
sir.
Okay, thank you everyone.